In Module 8, we did graphing of quadratics in different forms. We have standard form right here, and we have vertex form right here. We're going to take a look at 24. And our a value, no matter what form it is the coefficient of x. And so in this case, it's -1. Our jumps are always in the form of a 3 times the a value and 5 times the a value. So in this case, it's going to be -1, -3, and -5. Our vertex is given to us in vertex form with one difference. The x value right here, because it's inside the parentheses, is going to be opposite. So it's a -4 in our equation, which means it's a +4 for the vertex. The +1 on the outside stays +1. So let's graph that. 4, 1 is right here. And then my axis of symmetry is always x equals the x spot of my vertex, so that would be 4. And so you can imagine there's a little dashed line right here. And then I can do my jumps from there. So I go down 1 to the right one and down 1 to the left one. And then from those points, I'm going to go down 3. And then I'm going to go down 5. And then I can connect with the curve. And I have my graph, and I can get some of my information from the graph. Like right here is my x-axis, so these are my x-intercepts. So I have an x-intercept at 3, 0, and I have my other x-intercept at 5, 0. Now my y-intercept is not viewable from the graph, so I can solve to get that because I know that the x value has to be 0 if it's a y-intercept. So I go to my original equation, and it's going to be -1 times 0 minus 4 squared plus 1. You can put that whole thing in your calculator, or you can work it out piece by piece. That's going to be -1, and then 0 minus 4 is -4, but -4 squared is -4 times -4, or 16. And I still have my plus 1, so now I have -16 plus 1, which is -15. And that makes sense that it would fall, further in the negative direction here. Just one quick note about 23, just to remind us that the x spot of our vertex is going to come by doing the opposite of b over 2a, which is also going to give us our axis of symmetry. And then once you have your vertex, once you get your x value, you're going to plug that in to your original equation everywhere you see an x and solve for y. 25 and 26 are the same type of problem. I'm going to do 26. Our vertex, you're just going to start by labeling your points here. So our vertex in this case is our maximum, and I can see that it's at 3, 8. And my y-intercept I can see right here on the y-axis. So that is going to be 0, -10. And then along my x-axis, I'm here at 5 and 1. So 1, 0, and 5, 0 for our ordered pairs. And then our factored form and our standard form and our vertex form all have the same a value. And so we have to look at the graph to find our a value. We know it's negative because our graph is opening down. And what we look on our graph is to see how far do we have to go down before we go over 1. And in this case, we are going down 2, so our a is going to be -2. So no matter which form we're talking about the same a value. Now for factored form, we are looking at the x-intercepts. So it has our 2 parentheses like this. And remember that inside the parentheses are going to be the opposite. So it's going to be x -1 and x -5. And that's because if I plug this 1 in, 1 minus 1 is 0. If I plug this 5 in, 5 minus 5 is 0, which gives us our x-intercepts. For standard form, I'm going to do in just a moment, we are going to multiply together our factored form. I think that's the easiest way to do it. I do know some pieces of it, but I don't know that middle term. So I know that there's going to be an x squared here. And my standard form tells me the y-intercept. So if I know my y-intercept is negative 10, I know that it's going to end with minus 10. But we're still going to have to multiply our factored form out. Let's just label this here that the factored form is the x-intercept. And then, of course, the vertex form is going to use our vertex. And this is what vertex form looks like. Remember, it's x, and then it's going to be minus 3 because it's a plus 3 here, so it's going to be the opposite in the equation. And then the 8 stays a positive 8. So now we have to do a little work in order to find our middle term here. So I always like to take our factored form and multiply it out. I'm going to use the box method just to keep myself organized. So I have x minus 1 and x minus 5, and we're going to multiply the outside to get to the inside. So x times x is x squared. X times negative 1 is negative 1x. X times negative 5 is negative 5x, and negative 1 times negative 5 is going to give us positive 5. So this right here is x squared, and then I have a minus 5x and a minus 1x, so that's minus 6x plus 5. However, that is being multiplied by the a value, which is negative 2. So then that distributes to each part here. So that's where we're getting the negative 2x squared plus 12x, and then, let me erase that, and then that would be minus 10. And if you look here, I have a minus 2x and I have the minus 10, so it makes sense that we did this correctly and that this would be plus 12x as my middle term.